Hey guys, what's good? In the previous video, we made rectangle a base class, so now in this video we're going to make cube a derived class. So where do we begin? Well, we're going to begin with the header file of cube. So let's log, or I guess edit, the cube header file. And here we are. So when I create this class, for it to be a derived class, I need a base class to inherit from. So I'm going to denote that I'm going to inherit from the rectangle class by doing a colon, and then I'm going to say public rectangle. Also need to include rectangle.hpp, but here I denote that I'm inheriting from rectangle with this colon. So I have my class cube public rectangle. So what does this public keyword mean here? What does it mean in this context? Well, it means that I'm doing a public inheritance of rectangle. The protected data of rectangle stays at the protected level for the class cube, and the public data that's in public, all the public methods, they stay public with cube. Most of the time you're going to do an inheritance, you're going to do public inheritance. This is why like base classes should always have protected instead of private. Because if it was private, what happens if I do a public inheritance is that the private data stays private, but it's only private for the parent class. So I can't exactly interact with it like I could with the private data inside of cube. So because of that, I need it to be protected. Now that we are inheriting from the rectangle class, well, rectangle already has length and width attributes, so I don't need them anymore. I only need the depth, surface area, and volume attributes now. Everything else I inherited from rectangle, so I inherited area as well as perimeter. Not that I'll be using them, but it's still one of the great benefits of inheriting, because there might be some cases where I would have to use perimeter. I will use area for when I calculate a surface area. It'll shorten one function call. But anyways, so what remains the same has to be the cube constructors as well as the destructor. I don't need the length and width getters because rectangle has already done the work for me. I don't need set length, set width because again, rectangle has done the work for me. And then so here I have my print, and the only thing that's going to change here is that, well, I don't like how print is implemented in rectangle. So what I'm going to do is that, well, since print is going to be a method that's virtual from the parent class, since print is virtual for rectangle, when I do it here, when I want to add a different implementation of print, what I need to do is that with the declaration of print here, I'm going to say, okay, I inherited from rectangle, but I'm going to override this method, meaning now I can add a new implementation and I can make my own twist. And when this is done, this is actually called polymorphism. So what this means is that these methods are morphing at different layers of class inheritance, right? So here print at the cube level is going to have a different form than print at rectangle level. And that really wraps it up just for the header file, which is pretty neat because I didn't really have to change much. I mostly spent my time taking code out rather than writing code. I only really wrote override actually, and the rest of the code I just took out. Mostly because rectangle as a class has already done so much of the work for me in terms of the setters and getters for length and width, stuff like area and perimeter, things like that. And it's like, because I'm able to inherit that data, I only get to add on more with cube. So let's go with the implementation of cube to see how it goes. So here I wanted to include all three of the constructors as well as this destructor and the operators. Actually the operators I'm not going to touch. I'm going to leave them the same. But we're going to run through the other methods that we had before, and some of them we'll have to take out. And some of them we're not just going to be including at all because rectangle has already done the work for us. So with cube, how are we going to change cube? Well, we don't need length and width anymore. What we're actually going to do is that we're going to call the unparameterized constructor for rectangle. And then we have our depth of 1, surface area of 6, and volume of 1, which is pretty sweet now. And here I'm going to get rid of this, get rid of that, and I get to get rid of these three attributes. And instead of calling these declarations for the attributes, I'm going to call the parameterized constructor for rectangle. And I mean, pretty much what I'm doing is that I'm passing as much as work as I can to rectangle, because rectangle can already deal with length and width. So why do I need to do anything else with it? If I do anything else with it, that's going to be extra work. And the same thing can be said here. So instead of having length, what I'll do, actually I should not get rid of C length. I will have rectangle, C length, and then we're going to do C underscore width, call that, and then I can get depth right here. We'll be fine. And here, I mean, we're just doing less work. We are doing less work. I can call the constructor here, and I can cut and you know, I initialize all my attributes with the data here. I can let rectangle do its own work with length and width by calling its constructor, and I'm pretty much making rectangle do as much work as it can with length and width, so that way I only need to worry about depth, surface area, and volume. And we can actually leave the destructor untouched, and here, I mean, I can leave all this stuff untouched and we'll be fine with the operators here, so there is no problem with that. So even though that I'm inheriting from rectangle, and usually rectangle is left to deal with length and width, because cube is inheriting from rectangle, I can access these attributes just like it's as if I declared it within cube itself, which is a great added benefit for inheritance. One of the key properties of inheritance is that I'm able to access these methods just as if they were part of the cube class. But in reality, when I call these two, it's going to go up a level and call rectangles set length and set width methods. So why don't we go down the line about what we have in our header file. So what comes next is that we're going to have our depth getter, which we're simply just going to return depth. Well, it's exactly the same as we did before, as well as that we're going to have our getters for surface area as well as volume. And again, these getters are exactly the same. So now let's go about set depth. So we're going to have, because we're creating a method for the cube class, again, we need the class preceding the name of the method with class : So here I'm going to have set depth, and then just some int called depth, and we're going to go about doing our little check, you know, to see if depth is greater than 0. If it is, then we're going to set our private attribute to equal to the input value. Otherwise, we're going to do nothing. And then we need to go about calculating surface area, if I could spell it correctly, as well as calculating volume. But hold on, I have actually a problem with this, because what happens when I call set depth and what happens if I call set length and set width? They are not going to update surface area and volume. They're going to update area and perimeter. Oh shoot. What I need to do now is go back to my rectangle header file and make these setters virtual, because now I need to add additional functionality to rectangle setters, so that way they apply better to my cube class. Because if I don't, well, when I call set length and set width, it'll update the length and width attributes along with the area and the perimeter. However, it will not update surface area and volume, and that's a problem for me, because surface area and volume are directly dependent with length and width. So why don't we go and take a look at rectangle. Oh, that's this C++ file. I need to look at the header. So I'll go here and I'll say virtual and virtual. So now we can add additional functionality to these two setter functions in our cube header file. So what I'm going to do here, similar for me having my print override, I'm going to have my set length as well as set width with the override keyword there. So now I'm going to change this to width. Right, and again, I mean, there's no problem with going to the header file of your base class and having to make some methods virtual and stuff like that, because one, I mean, I couldn't have predicted this. I didn't predict this at all when I created Rectangle. And just now I caught myself saying, oh shoot, because surface area and volume depend on these two methods, if I change them, I need to update my surface area and volume. And you know what? I'm going to introduce you to another keyword. So while override will add additional functionality to these two, if some other shape, let's say like tesseract, right, a fourth dimensional cube, inherits from cube, it'll be able to edit these, which for the case of length and width I want. But let's say, for example, I don't want them to edit print. So instead of having override, I'm going to replace override with the keyword called final. So what final means is that this print method is going to be the final override for this class and for rectangle. So if I have my tesseract inheriting from cube, it cannot override print. It's going to inherit print as it is, because print is going to be the final override for that method. And using this keyword is typically resolved for a derived function that you know is going to be the most derived function, and no other class will inherit from it. But if you expect that different methods will may or may not want to update and do polymorphism on these methods, you probably want to just keep it out override instead of final. So override lets you override the previous virtual methods, and future classes that can inherit from this class can also override these methods. However, when we get to final, that means that for this class, this is the final override. Any other class that inherits from this one cannot override methods that have the final override. With that being said, let's go and implement set length and set width. So we'll go back and go to the cube implementation. So I'm going to go past my getters. So I'm going to go here, I'm going to say void cube set length int length. So notice that here when I'm typing, I'm not having any override or final or anything like that. And that's just because I don't need to. It's already declared in the header file. So now what I'm going to do is actually something really neat. I'm going to directly call my parent's method. I'm going to call the parent class method. So let's take a look at how this works. So here I'm overriding the set length function. So here I'm overriding the set length method that belongs to the rectangle class. I'm doing a new implementation. So how does it start? Well, here I'm going to call the parent class's set length method itself. Right? So why would I want to do the check like I do in depth when I've already have it done and set length as part of rectangle? So here I get to call the rectangle method specifically, and then I'll update surface area and volume. And you know what? Let's do a paste, and we'll do the same for width. And this is honestly pretty snazzy, because I'm able to abuse this object-oriented programming to call parent methods and add additional functionality with my own methods. And it's really nice because I really get to choose and exercise control on what methods I want to keep and how I implement them. Now, why don't we go about calculating the surface area and the volume? These are not too different from when we created it as an independent class. And really the only thing that's different is that I call area here. And actually, if I wanted to, I can say rectangle area, right? This is an explicit call to the area method, but here this is an implicit call to the area method that belongs to the rectangular class. And actually, let me say that again. This is an explicit method call to the parent class of rectangle. Again, the emphasis is that it is explicit. And here we have an implicit method call to the rectangle class. It is implied that it's being called by the rectangle class because for my cube class, I did not declare any area method. So that's why it's implicit. Finally, let's move on to our print method. And I mean, the print method actually isn't going to change much. It's just going to, the real difference comes from it being declared in the header file as like a final function or method override on a virtual method. And honestly, outside of the header file, the implementation for this method is nothing special. Actually, it's pretty much going to be the same as it was in the independent class. Right, I'm just going to be printing out all the methods, and I choose not to print the area and the perimeter of the class because, I mean, this is three-dimensional, right? We need to be taking account for our depth parameters. So, I mean, when we talk about area, that's kind of useless at a 2D scale. I mean, at a 3D scale, right? So I just only print the length, width, surface area, volume, and depth. I really don't need to do the perimeter or the area because that's really more important to the two-dimensional side of the method rather than the three-dimensional side. And speaking of making it a method, I forgot to put cube : before the method name. And actually, let's check that all these are like that. Yeah, this is all good. So the operators are the same. So again, because we're inheriting from rectangle, we're actually able to access the length and width attributes directly. And because I also inherited the getter methods, I'm able to call them just as is. Finally, I call set depth, which will make sure that I update not only the depth attribute, but the surface area and the volume. And I essentially repeat the operations here. And again, with the multiplication, I use the setters for all three of them because I don't trust I. With cube C here, I know that it's either going through the set blank method or it's going to be 1. So I have no problems here. I don't trust I because I can be anything. And again, like I said before, these are largely the same. So why don't we go to main and check that our cube works. And it's a little weird because, I mean, we've done so much work for this cube class. However, our main's not going to change. At least, well, it's not supposed to. Let me run make clean. Okay. Hopefully there's no errors. Oh no. Oh, I need to look at main. Since cube already inherits from main, if I do a pound include rectangle and then the pound include cube, it will do a definition. And dang it, it needs to be a double colon, not a single colon. Oh, the very first one. Ooh, that's rough. Okay, now this should work. Hopefully it does. It does without error. And we've changed our implementation from creating 2 independent functions to creating 1. We've changed our implementation from implementing 2 independent classes into making a base class and then a derived class. So the really neat thing about the base class is that the base class will do a lot of heavy lifting for the derived class. If we take a look at cube, well, if we go to the bottom, 100 lines. That's how much it takes us. So if I check out, if I go to my independent classes folder where cube is there, and we go to the bottom, well, we just say 14 lines. Well, even though it is 14 lines, I mean, the implication's bigger than this. It means that we can make classes, base classes that do a lot of the heavy lifting, and you can write a bulk of reusable code inside of those base classes, and then you can write derived classes that can be implementations of the base class or more concrete implementations of the base class, or kind of like, well, here we have like a shape that begins as a 2-dimensional shape, right, which is rectangle, and then we bump it up to 3 dimensions, which is a cube, right? So it's kind of like, I don't know, making a code that depends on other code. But this is essentially a tool, well, for you to be lazy, right? Because if the base class is doing a lot of the heavy lifting, for the derived class, you don't need to do much. You just need to write a little bit of extra code. Maybe you need to override some methods to update what you want to do for your class. But for the most part, if you have a base class that does what it needs to do, you won't have to write that much code for your derived class. Anyways, this is an example of single inheritance where cube only inherits from rectangle. And in the next video, we're going to set up creating a base class as well as something called an abstract class. So that way, when we have another derived class, our derived class can inherit from our base class that's a little bit more concrete and our abstract base class, which we will define in the future. Thanks for watching.